Okay, guys, so let's look at some important graphs in this video. So the first graph that I'm going to look at is x equal to y. So which essentially means that if I put x as -2, I'm going to get -2 as my output. If I take -1 as the input, -1 comes as the output. 0 gives me 0, 1 gives me 1, 2 gives me 2. So if I will denote this graph, let's graph it. So if I have, this is your y-axis, this is your y-axis, and say this is your x-axis. Okay, let's take points. So this is 0, 0. This is -1. You get -1 as the result. So this is -1, -1. -2 gives you -2. So -2, -2. 1, 1. Similarly, 2, 2, and so on and so forth. So that essentially means that it's going to be a line passing through all these points, which is a 45-degree line. So it's basically bisecting this 90-degree in equal parts, so 45-degree line, right? So that's our first graph. Next graph is x square. So x square. So if I give value, if I give x value -1, I'm going to get 1 because square of -1 is 1. -2 will give me 4, 0 will give me 0, 1 will give me 1, 2 will give me 4 again. So if I may graph it, and then let's see what it will look like. So let's take this as our y-axis, and x-axis. See, because y will never be negative, so I am taking more space for the positive y. So 0, 0, then -1, 1. So -1, 1 is here. 1, 1 is here. 1, 1. -2 is it's going to get 4. -2, 4. So it's going to be here. -2, 4. And similarly, 2, 4 is going to be here. So clearly, if you join, it will not be a straight line. It will be a curve here. So it will curve down like this, and then it will go up again like this. So it's basically a parabola. So it's going to be smooth actually here. It's not linear, but smooth. And what is smoothness and all, you will get to know in the coming videos. We will be talking about, of course, smoothness. So this is what is sort of the graph of x square. Then an important function, x cube, also is a very, very important function in terms of a graph. X cube graph is also something that you must always know. So if x is -1, y is also -1. If x is -2, y is -8. If x is 0, you get 0. So it is passing through 0. 1 gives 1, 2 gives 8. So essentially, if you notice what you are getting, your input could be positive, negative, your output could be positive, negative. So let's graph it. So suppose this is your y-axis, and this is your x-axis. Okay, so it's going to cross 0, 0. Then for 1, you are getting 1. For -1, you are getting -1. But then suddenly, for -2, there is a jump and you are somewhere very far. So of course it cannot be linear. And similarly, at 2, there's a jump and you are like very far at 8 because it's cube. So what's really happening is you have a curvaceous thing here, and it's then going up. From here it will join 1 1, and then it's going to go up pretty steep. So this is the kind of graph that you have for x cube. We will of course talk in detail also about curvature and all. Just I guess you must relax right now. For now, I just want you to know these graphs thoroughly and how you can graph it just by point formula. Square root. So if you have square root of -1 is not possible. So square root will be of positive values only. 0 square root will give you 0. 1 will give you 1. 2 will give you √2. 4 will give you 2. Right? 4 will give you 2. So if I may graph it, here, let's graph the axis. Let's graph our axis. So you have, this is your y-axis, and this is your x-axis. And we need to graph root. So graphing root x will give us something of this sort. So 0, 0, 0, then 1, 1, 1, 1, right? When it is 2, you actually have √2. √2 is 1 point something. So it's somewhere maybe here. So 2 √2. And then when it is 4, so this is for 3, this is for 4. When it is 4, it is 2. So it's going to go here. So if you see, it is not a linear graph because the movement is not such. So there will be a curve. There will be a curvaceous kind of a growth here and something like this. Okay, so that's what is √2. The next one I am looking at is 1 by x. Now, when it is written 1 by x, you can have negative and positive inputs. So if x is -1, you will get -1. When x is -2, you will get -1 by 2. When x is 0, you have infinity. So at 0, 0 is not a part of the domain actually. So x should not be equal to 0. This is just for our knowledge that yes, it will go to infinity when x will be 0. Then at 1, 1, at 2, 1 by 2, at 3, 1 by 3, and so on and so forth. So if we may graph it, what we will get, this is your y-axis, say this is your x-axis. My input would be positive, negative. It's not crossing 0, 0. At 0, in fact, you have infinity. At 1, you get 1. At -1, you get -1. Otherwise, you get half. At 2, you get half. Then 1 by 3, and so on and so forth. And here, you'll be getting it increasing towards infinity. Similarly here, at 2, you have -half, and so on and so forth. And this will go to -infinity. So the graph will be a rectangular hyperbola. And since there is no restriction on x, so x could be negative also, positive also. When x is negative, y will be negative. When x is positive, y will be positive. Okay, so this is the graph of 1 by x. Similarly, interesting graph, modulus of x. Mod x essentially will be, when x is 0, you get 0. When x is minus 1, you get 1. When x is 1, you get 1. When x is 2, you get 2. When x is minus 2, you again get 2. So what kind of a graph it is? It's a graph where y is always positive. Y is always positive. So this is y-axis. And this is, say, x-axis. Again, since y will always be positive, so I'm keeping it here. So, but the fact here is, it's different from x square in the sense you don't have curvature here, any y. Because see, the changes are sort of linear. So 1, 1, minus 1 also 1. 2, 2, minus 2 also 2. 3, 3, minus 3 also 3. So there's a same, it's a linear curvature that you have. So it's sort of linear. Not sort of, it is linear. Because the changes are such. The change, the increment is such. So this is what is the graph for mod x, which looks like x square, but in x square what happens? The moment you're squaring, you will have that curvature in the graph. So that's how it will be different. These are the major graphs that you must actually have a picture of in your head the moment a function appears in front of you, which is of this nature. Then it should be very clear in your head what kind of a